Picture a massive, high-speed manufacturing line. Hundreds, maybe even thousands of parts are flying through production every single hour. It's this incredibly precise ballet of engineering, right? But here's the terrifying reality about all that speed. It literally only takes one bad part, just one microscopic deviation, to ruin an entire batch, trigger a massive recall, or completely shatter a customer's trust. Welcome to This Explainer. Today, we're diving into the intense, high-stakes mission of defending a production line from the sheer chaos of defective parts. We're going to break down the actual standard operating procedures used to control non-conforming products and show you how a factory builds a literal defense in depth to catch defects way before they ever see the light of day. Let's get into it. Okay, so here's our roadmap for navigating this multi-layered quality control system. We'll start with the zero defect goal, move on to guarding the front door, jump into factory floor quality control, and wrap up with the final disposition verdict. Starting with Section 1, the zero defect goal. We have to set the standard before we look at the exact protocols. The sheer ambition behind this mission statement is honestly pretty striking. Right from the source material it says, to implement a system for controlling the non-conforming products to ensure zero defect supply. That sets an absolute standard for everything that follows. Notice they aren't just trying to minimize bad parts or keep defects to some acceptable minimum. No, the goal is zero. And you have to understand, achieving this zero defect supply isn't just some nice-to-have preference for management. It is rigidly required. Building a completely watertight system for controlling non-conforming products is a fundamental necessity if you want to meet the strict, globally recognized ISO 9001:2015 quality system requirements. It's basically a mandate for operational excellence. If a factory wants to be taken seriously on the global stage, they absolutely have to prove they have the systems in place to back this up. Moving to Section 2, guarding the front door, which focuses on incoming materials. You can't build a perfect product if you start with flawed ingredients, right? So let's break down the actual standard operating procedure for incoming material. Now, this workflow might look a bit dense at first glance, but don't worry, we're going to break this down step by step so you can see exactly how the trap is set for defective materials right at the factory gates. It all begins the moment a supplier drops off a shipment at the gate or the store. Immediately, a quality assurance inspector steps in. Honestly, think of the QA inspector as the factory's strictest bouncer. They don't just wave a delivery through because it showed up on time. They conduct a rigorous inspection of the received material, checking it against established standards, and the MTC. That's the Material Test Certificate. Essentially, the material has to prove it belongs there. But here's the million-dollar question. What happens if the incoming material fails this initial inspection? Imagine a massive shipment arrives, something the production line desperately needs right now to stay on schedule, and it simply isn't up to par. The factory has to act instantly to prevent those bad parts from accidentally blending in with the good inventory. Well, there is a stark contrast in how materials are treated based on that bouncer's decision. If the material is deemed okay, it's a totally smooth pathway. It gets an OK tag, which is basically a VIP pass, and goes straight into the main store for regular use. But if it is not okay, it faces immediate isolation. It gets sent to separate storage, slapped with a highly visible red rejection tag, and the head of quality assurance, the HODQA, is immediately informed. There is absolutely no gray area here. The threat is quarantined instantly. Let's move into Section 3, factory floor quality control, specifically looking at the in-process phase. Once those materials are actively being transformed, mid-production control becomes incredibly complex. The machines are running, parts are being cranked out by the second, and finding a defect here triggers a massive rapid response protocol. Picture the scene. Regular production is humming along perfectly. During this, an in-process inspection occurs. The QA inspector is walking the line, spot checking. Suddenly, they find a product that is not okay. Immediate triage kicks in. They identify the flawed product and throw it straight into the reject bin. No hesitation, no second guessing. But obviously, just throwing away one part doesn't solve the underlying mystery. This triggers a really intense micro-narrative on the factory floor. Was this just a fluke, just an isolated flaw, or is the tool dulling, the calibration totally off, or the entire machine failing? The operators are suddenly racing against the clock to figure out the true scope of the problem before hundreds of bad parts are created. So, this next step is absolutely crucial, the 10-minute check. The SOP dictates that QA must rigorously check the very next 10 minutes of production. If everything in that window is okay, cool, it was a fluke, and production continues safely. But if even a single other product is found to be a reject during that 10-minute window, the protocol hits a dramatic failsafe. Stop the machine. They literally pull the emergency brake on production and instantly inform the head of QA. Now that the machine is halted, an intensive, escalated review kicks in. They don't just tweak the machine and restart. No way. They must inspect the materials spanning all the way back to the last known good inspection, and they must do it in the direct presence of the QA head. Leadership is brought right down to the floor because the integrity of a whole batch of products is now on the line. And if, during that deep dive inspection alongside the QA head, they find any product that is not okay, the flowchart demands the ultimate containment action. Hold the complete lot. Nothing from that production run is allowed to move an inch forward. The entire batch is frozen in place until a final decision can be made. It's a full lockdown. Which brings us to our final act, Section 4, the final disposition verdict, the fate of the product. This is where the head of the QA department steps in to act as the ultimate judge. A non-conforming product essentially faces a few distinct verdicts. If it's a hard rejected, it gets the red tag and stays dead in the rejection area. Done. If it's incoming material that failed, it might be returned and sent straight back to the supplier. But sometimes a part can actually be salvaged, receiving a verdict of reworked, which requires careful segregation and correction. Now, there is one other highly specific verdict called accepted under deviation, but I really want to focus on the incredibly strict criteria required for a part to be granted this status. A flaw might be present, say a tiny scratch on a totally hidden surface, but it can only be accepted if it passes 3 rigid tests. First, the parameter must absolutely not affect the part's performance. Second, it must not affect the performance of the very next process on the line. And above all, it must still completely meet the customer's requirement. This just proves that even when they're accommodating a deviation, the core quality is never, ever compromised. And for those materials that were granted that rework verdict we mentioned earlier, yeah, they certainly don't get a free pass once the fix is applied. They are forced to undergo a grueling reinspection. Only if they are deemed perfectly okay do they finally earn the okay tag. If they fail this second chance, they are rejected permanently and kept in the rejection area. The whole system is a closed loop. Nothing escapes without verifying its quality. So from the vigilant bouncer at the loading dock, to the 10-minute fail-safe on the factory floor, all the way to the strict courtroom of the QA head's final disposition, controlling non-conforming products is a relentless, proactive battle. It's a system literally designed with overlapping layers of security. As you think about this incredibly tight methodology, I'll leave you with this question to consider about your own processes. Are your own defense lines truly strong enough to catch every single defect before it reaches the customer? Because in the pursuit of that zero-defect reality, hope is definitely not a strategy. Only a bulletproof system is. Thanks for joining me on this explainer, and keep learning.